All right, so let's look at a couple more examples for 4.7. So this one, number three, we have a new cell phone has been selling 200 units per week at in the electronic store at a price of 220. Market survey indicates that for each $10 rebate offered to buyers, the number of units sold will increase by 20 per week. Find the demand and revenue function for this phone. How large rebate should we offer? Um, all right, so this one, it doesn't say this explicitly, but we are assuming that the demand function will be linear. And so what we need to do is get a couple of ordered pairs here. So we have one. So we have 200 units is going to sell, well, at $200, I guess we should say, we'll sell 200. That's not right. 220. Sorry. 200 units at map to $220. And then we can use this sentence to get another ordered pair. So indicates that for each $10 rebate, so the price is going to go down $10, the number of units will go up by 20. So then we have units will go up 20, so 220 units at a price of 210. And so there are ordered pairs. Now we're going to calculate the slope for this between these 2 points. So the slope will be 220 minus 210 over 200 minus 220. And so that'll give us a slope of negative 0.5. Now you could also do this as the dollars is the Y unit, the units is the X. And when one increases, the other decreases, or vice versa in this case. So a decrease in price corresponds to an increase in units. So the slope is going to be negative, and then the slope is just the ratio of 10 over 20. So we could do it that way as well. All right, now we're going to find the y-intercept for this. So negative 0.5x plus b, plug in either of the points. So 220 equals negative 0.5 times 200 plus b. And so we see that b is 320. And so our demand function, d of q, is negative 0.5x plus 320. So there is our demand function. The revenue function is just going to be q times the demand function. So q times negative 0.5. I guess we should put q there. Q plus 320. Distribute the q, and we get negative 0.5 q squared plus 320. And so there is our revenue. There is our demand. Now, how large a rebate should we give to maximize revenue? So we're going to take the derivative of the revenue, find r prime. We get negative q. Sorry, that should be 320q. So negative q plus 320. Set that equal to 0. And q is 320. All right, so now 320 units, what price does that correspond to? So d of 320 is negative 0.5 times 320 plus 320, and that corresponds to 160. So then what's the rebate? The rebate is the original price with no rebate, which is 220, minus the optimal price that we have. And so the rebate then would be 60. All right. So you may need to work through that one a couple of times to kind of see all the parts to it. But once you do it a couple of times, it's not too complicated, I don't think. All right. So the last one is talking about elasticity of demand. So it's helpful to have a way to measure how strongly a change in price influences a change in demand. So Price fluctuations are going to affect how much demand there is for a product. Exactly how much depends on the product and the amount of the price change, I guess, also. Um, so elasticity of demand, we have this formula. So price divided by the quantity over the derivative. So let's look at this example. So a tool company estimates that the monthly demand for their power drill is related to the price, P for each drill by P equals 185 minus 0.06 Q. So we're going to compute the elasticity of demand for $50, price of $50. And then I'll give you the answer for the 95, and then you can see if you can get it on your own. I think you'll see these are not too bad. All right, so first we need to for the $50, what's the quantity? So 50 equals 185 minus 0.06 Q, and I will spare you the steps here. Q is 2250. The derivative of the price function is just negative 0.06. And so now we have P is 50, Q is 2250, the derivative is negative 0.06. And of course, if you had one where it's a function, this was a function, you plug in the 50 to get what it is at that point. But this is just a constant derivative, so we don't really have to worry about it. So the elasticity function is P over negative P over Q over dP over dQ. And we can just plug all these in. It's pretty straightforward. So we have negative 50 over 2250 all over negative 0.06. And put that in the calculator, and we get 0.37 for elasticity. So pretty straightforward. This one, as long as you have that formula, it's fairly easy to calculate. For $95, and I'll just give you the answer, and you can see if you can get it. For $95, E of Q is 1.06. So see if you can get that one. If you have any questions, feel free to email me.